The world of data science is experiencing a revolution. Artificial intelligence, or AI, is rapidly changing the landscape. AI assistants like ChatGPT, Claude, and Gemini are emerging as powerful tools. These tools aid data scientists in building robust machine learning models. This essay delves into the capabilities of these AI assistants. We will explore their strengths and weaknesses. Our focus will be on their applications in 8 key stages of the machine learning pipeline. Understanding these stages is crucial for data scientists. It allows them to leverage AI's potential effectively. We'll use the example of online payment fraud detection. This real-world application highlights the practical use of these AI tools. Throughout this exploration, one thing remains clear: human expertise is irreplaceable. AI assistants are powerful tools, but they are not replacements for human intelligence and judgment. This essay aims to guide data scientists. We want them to understand how to choose the right AI assistant. We also want to emphasize the importance of human oversight in every step of the machine learning process. Before embarking on the journey of building a machine learning model, a crucial first step is defining the problem. This is where human ingenuity takes center stage. AI assistants, while powerful, lack the contextual understanding and critical thinking skills needed for this initial phase. Defining the problem involves clearly articulating the business objective. It requires identifying the specific questions that the machine learning model aims to answer. For instance, in our online payment fraud detection example, the problem definition might be: develop a machine learning model to predict the likelihood of an online payment transaction being fraudulent. This step demands a deep understanding of the business context. It also requires knowledge of the data available and the potential implications of the model's predictions. AI assistants can assist in gathering information. However, the ultimate responsibility of defining the problem lies with human experts. They possess the domain expertise and critical thinking skills necessary to frame the problem effectively. With the problem defined, the next step is collecting the data. This data will be used to train and evaluate the machine learning model. This stage, like problem definition, heavily relies on human intervention. AI assistants play a limited role here. Data collection involves gathering relevant data from various sources. These sources may include databases, APIs, or web scraping. The quality and relevance of data directly impact the model's performance. Therefore, human judgment is crucial in selecting appropriate data sources. In our fraud detection example, this involves gathering data on past transactions. This data would include information about the customer, the merchant, the payment method, and the transaction amount. It may also involve collecting data on known fraudulent activities to help the model identify patterns. While AI can automate some data collection tasks, it's crucial to remember that AI assistants cannot fully grasp the nuances of data relevance. Humans must ensure the collected data aligns with the problem definition and is free from biases that could negatively impact the model's performance. Once the data is collected, we move into the exploratory data analysis, or EDA phase. Here, AI assistants start to shine. They can significantly aid data scientists in uncovering valuable insights hidden within the data. EDA involves analyzing the data using statistical methods and visualizations. This helps understand the data's characteristics, identify patterns, and detect potential issues like missing values or outliers. AI assistants excel in this domain. AI tools like ChatGPT, Claude, and Gemini can generate descriptive statistics. They can create insightful visualizations such as histograms, scatter plots, and correlation matrices. These visualizations assist in understanding the relationships between different variables. This can reveal hidden patterns that might be difficult to spot manually. For example, in our fraud detection case, AI assistants can help visualize transaction amounts over time. This might reveal suspicious spikes or trends. They could also analyze the correlation between transaction location and fraud likelihood. These insights, driven by AI, provide valuable guidance for the subsequent feature engineering stage. Section 5, Feature Engineering: Crafting Powerful Predictive Variables. Feature engineering is the art and science of transforming raw data into features. These features are then used as input for the ML model. This stage is arguably the most crucial in the ML pipeline, and it's where AI assistants can be incredibly powerful. Feature engineering involves selecting, transforming, and creating new features that best represent the underlying patterns in the data. This often requires domain expertise and creativity. However, AI assistants can significantly aid this process. AI tools can suggest relevant transformations based on the data type. For numerical features, they might recommend techniques like standardization or normalization. For categorical features, they might suggest one-hot encoding or label encoding. They can even help create new features by combining existing ones. For instance, in our fraud detection example, AI could suggest creating a new feature. This feature could represent the ratio of the transaction amount to the average transaction amount for that particular user. Here's a Python code snippet demonstrating feature scaling using scikit-learn, a task AI assistants can aid with. Python from scikit-learn pre-processing import standard scalar. By automating these tasks, AI assistants free up data scientists to focus on more complex feature engineering tasks. This allows them to apply their domain expertise and creativity to design even more powerful features. Section 6. Model selection, choosing the right tool for the job. With a set of engineered features, the next step is selecting an appropriate ML model. The choice of model depends on various factors, including the nature of the problem, the type of data, and the desired outcome. AI assistants can be valuable partners in this stage. They can analyze the data and recommend suitable models based on their knowledge base. However, it's crucial to remember that these recommendations are just starting points. For our fraud detection example, an AI assistant might recommend a logistic regression model for its simplicity and interpretability. Alternatively, it might suggest a more complex model like a random forest or XGBoost if the data is highly dimensional and nonlinear. These recommendations are based on the AI's understanding of the data and the strengths of different models. However, the final decision should always be made by a data scientist. They can consider factors beyond the AI's scope, such as the model's interpretability, computational cost, and deployment constraints. Section 7. Model training and evaluation, breathing life into algorithms. Model training is where the selected algorithm learns from the data to make predictions. This involves feeding the model the prepared data and adjusting its internal parameters to minimize errors. AI assistants can play a significant role in this phase by generating code for training and evaluating models. For example, an AI assistant can provide Python code using libraries like scikit-learn or TensorFlow to train a logistic regression model. Python from scikit-learn, linear model, import, logistic regression from scikit-learn, model selection import train, underscore test underscore split, x underscore train, x underscore test, y underscore train, y underscore test, equal sign train test split, x, y, test underscore size equal sign 0, 2, model equal sign logistic regression, model dot fit x train, y underscore train. However, AI's role in this stage goes beyond just code generation. They can also assist in handling common challenges. One such challenge is dealing with imbalanced data sets, a frequent occurrence in fraud detection. AI assistants can suggest techniques like oversampling, undersampling, or using different performance metrics beyond accuracy. Despite these capabilities, it's crucial to emphasize that AI assistants shouldn't operate in a vacuum. Human oversight is paramount. Data scientists must evaluate the model's performance, understand its limitations, and ensure it generalizes well to unseen data. Section 8. Model deployment. From prototype to production. Once the model is trained and validated, it needs to be deployed into a production environment to start making predictions on new data. This stage involves integrating the model into existing systems, which often requires software engineering expertise and a deep understanding of the deployment infrastructure. AI assistants, while having limitations in this domain, can still offer valuable guidance. They can suggest suitable deployment platforms based on the model's requirements and the organization's infrastructure. For instance, they might recommend cloud-based platforms for scalability or edge devices for real-time predictions. However, the actual deployment process typically involves tasks beyond the scope of current AI assistants. These tasks include setting up servers, configuring APIs, and ensuring the model integrates seamlessly with existing systems. Therefore, close collaboration between data scientists and software engineers remains crucial for successful model deployment. Section 9, monitoring and maintenance ensuring long-term performance. Deploying an ML model isn't the end of the journey. Continuous monitoring and maintenance are essential to ensure its long-term performance and adapt to evolving data patterns. AI assistants can play a supportive role in this phase. They can suggest monitoring tools and techniques. These suggestions help detect performance degradation or data drift. They can also assist in automating some aspects of model retraining. This ensures the model stays relevant over time. However, human expertise remains indispensable in interpreting and monitoring data. Humans are best equipped to diagnose issues and make informed decisions about retraining or model adjustments. This ensures the ML model continues delivering accurate and reliable predictions. Section 10. Choosing the right AI assistant for your needs. Selecting the ideal AI assistant for your machine learning project hinges on several factors. Project requirements. Different AI tools excel in various domains. Some are better at code generation, while others are more adept at data visualization or natural language processing. Understanding your project's specific needs is crucial. Technical expertise. The technical proficiency required to effectively use each tool varies. Some tools are more user-friendly, while others demand a deeper understanding of programming and machine learning concepts. Integration capabilities. Consider how well each AI assistant integrates with your existing tools and workflows. Seamless integration can significantly improve efficiency and productivity. Cost. AI assistants come with varying pricing models. Assess your budget constraints and choose a tool that offers the best value for your investment. Section 11, conclusion, the indispensable human element in AI-driven machine learning. The rise of AI assistants like ChatGPT, Claude, and Gemini marks a paradigm shift in machine learning. These tools empower data scientists. They automate tasks, offer valuable insights, and accelerate the model development process. However, it's crucial to remember that AI assistants are tools, not replacements for human intelligence. While they excel in specific tasks, they lack the contextual understanding, critical thinking, and ethical judgment that are fundamental to data science. The human element remains indispensable throughout the entire ML pipeline. From defining the problem to collecting data, engineering features, selecting models, and interpreting results, human expertise is essential. AI assistants should be viewed as powerful allies, augmenting human capabilities rather than replacing them. As we venture further into the era of AI-driven machine learning, the key to success lies in harnessing the power of these tools while recognizing the irreplaceable value of human ingenuity and expertise. The future of machine learning belongs not to AI alone, but to the synergistic collaboration between human and machine.